Assalamu alaikum. Am I audible to all?
यस सर।
जी बाकी सारे कहाँ पे हैं? We have only 10 participants. जी समीर, बाकी कहाँ पे हैं? सबको लिंक पहुंच चुका है?
जी सर, मैंने ग्रुप में भेज दिया लिंक।
यस सर।
ओके। So we'll wait for 1 to 2 minutes. Start. Okay, so is the screen visible to all?
यस सर।
Okay. Where's Akib? We have only 15 participants, including me, in the meeting right now. लिंक सब तक पहुंच गया?
जी सर, लिंक मैंने ग्रुप में भेज दिया, जो कोई क्लास कर अनाउंसमेंट करूँ।
ओके। टेक्स्ट इन योर व्हाट्सएप ग्रुप के क्लास स्टार्ट हो चुकी है, सारे के सारे आ जाएं। So, do you have any questions from the last lecture? that we had regarding root locus techniques. Any questions?
Not yet.
Okay. So we'll start with the control systems root locus techniques, and today we have the properties of root locus under consideration. So we know that this is the transfer function. This is the thing where we left in the last lecture, that T of S is equal to Kg of S divided by 1 plus Kg of S H of S. I repeat, am I audible to all, and is the screen visible to all?
Yes, sir.
Yes, sir.
Okay. So basically, this is the closed loop transfer function that we have, that is Kg of S divided by 1 plus Kg of S H of S. So open loop transfer function was G of S divided by only G of S. So and the closed loop transfer function for this was Kg of S divided by 1 plus Kg of S H of S. Okay, Samra, what are you saying?
सर आपकी आवाज नहीं क्लियर आई मुझे शायद आई गेस मेरा इंटरनेट का इशू है
Is this issue with everyone or सिर्फ समरा को ही आवाज नहीं आ रही?
सर आ रही है हमें सही।
जी, बाकी सबको भी आ रही है?
सर काइंडली
जी,
फिर लेक्चर साथ रिकॉर्ड पे लगा लें फिर मैं साथ में बाद में देख लूंगी
जी, it's on recording. It's on recording.
थैंक यू
Okay. So basically, we were talking about properties of root locus. Properties of root locus involve this closed loop transfer function, and this closed loop transfer function is the thing जो हम डिस्कस करेंगे, and this is the main thing जिससे हम आगे further properties निकालते हैं. So the first thing that we have is kg of s divided by 1 plus kg of s h of s. And this kg of s divided by 1 plus kg of s h of s tells us that the poles of the denominator, that is 1 plus kg of s h of s, are going to be the poles of our closed loop system. So the roots of this denominator, 1 plus kg of s h of s, are going to be the poles of our system. So in order to fulfill the condition of a root, what happens is that any point should be satisfying the equation 1 plus kg of s h of s is equal to 0. So that point would be considered as the root of this denominator, which is 1 plus kg of s h of s. So in order to satisfy, repeat, in order to satisfy the condition of being a root, the point has to satisfy the equation 1 plus kg of s h of s is equal to 0. So kg of s h of s is equal to minus 1. This tells us that the magnitude is equal to 1, and the phasor that is associated with kg of s h of s is going to be equal to 180 degrees or the odd multiples of it. So in order to prove any point to be a pole of kg of s h of s, kg of s divided by 1 plus kg of s h of s, that point has to satisfy two conditions. And these two conditions are the magnitude at that point should be equal to 1, and the phasor angle at that point should be equal to 180 degrees or odd multiple of it. So anybody has any question or confusion in this point? Is this clear to all? You're
सर ये
free to
पॉइंट
ask
एक बार
questions.
दोबारा रिपीट करोगे?
Okay. So basically what we have is kg of s divided by 1 plus kg of s h of s. This is clear that this is the closed loop transfer function?
Yes, sir.
Okay. So in order to be a pole of this closed loop transfer function, what happens is that the pole should be the root of denominator, right?
Sir.
Okay. So in order to be a root of denominator, the point should be a solution. The point should be a root of 1 plus kg of s h of s is equal to 0. So that point should make this denominator equal to 0, right?
Yes, sir. ऐसे ही है.
So kg of s h of s plus 1 equal to 0. From there we get kg of s h of s is equal to minus 1. And this kg of s h of s is equal to minus 1 tells us that the magnitude of kg of s h of s is going to be 1, and the phasor in the polar form is going to be equal to 180 degrees or the odd multiple of it. Is that clear?
Yes, sir. Clear है.
Okay. So now we have two conditions, that if a point is a pole of this closed loop transfer function, that is we call the closed loop pole, the point will make magnitude of this denominator kg of s h of s equal to 1, and the angle at that point would be equal to 180 degrees or the odd multiple of it. So you must be thinking that why is this important? Let's have a look at this figure. Okay, so if this point that is mentioned over here in the S-plane is a point on the root locus, if we want to check that this black point over here is a point on the root locus, he says that this point is -2 plus j3. So this is at -2 and the imaginary value of this is 3. So -2 plus j3 is going to be tested that whether this point lies on the root locus or it doesn't. So in order to make this, in order to check this thing, what we'll do is that we will verify two conditions on it. And the two conditions are the magnitude should be equal to 1 and the angle at that point should be equal to 180 degrees or the odd multiple of it. So basically at this point, we'll calculate the angle from all the poles and the zeros of existing system, the open loop poles and the zeros. And we'll sum that angle and find out what is the coming out value. So one point that needs to be considered over here is that we need to check that what is the angle being formed from each pole and each zero to that point, and also we need to add the angle of zeros and subtract the angle of poles. Why is that so? Because zeros come in the numerator, whereas poles come in the denominator. So the angle contribution by the zeros is positive, whereas the angle contribution by the poles is negative. Is this clear to all?
यस सर सर वो कुछ बच्चों को इन कर रहे हैं.
Okay, let me see. Thank you. Burhan, Abdul Rafi, Umar. Yes. Okay. So basically, this point clear to all, that the angle contribution by zeros is going to be positive and the angle contribution by poles is going to be negative. And why is that so? Because zeros are going to be in the numerator and the poles are in the denominator. So the angle contribution by the poles is negative and the angle contribution by the zeros is going to be positive. Is this clear to all? G, is this clear to all?
Yes, sir. Clear है.
Okay, thank you. So please keep on responding so that I can know that. G.
एक बार रिपीट करें.
Okay, so we have poles and zeros in the transfer function. The zeros come in the numerator, sorry, and the poles come in the denominator. For the zeros, the angle contribution, the polar form, if you remember the polar form, if something is in the numerator, it has a positive angle contribution. And if something is in the denominator, it has a negative angle contribution. So since zeros are in the numerator, we have a positive angle contribution to them. And since zeros, poles are in the denominator, we have a negative angle contribution for them. Okay, is that clear now?
Yes, sir.
Okay, so we have a point over here that is located at -2 plus j3, and we have two zeros and two poles over here. So we want to calculate the angle from this point to all the zeros and the poles existing, the open loop zeros and the poles, and that angle would be summed up, and we would check that this point is on the root locus or no. So in order to check that, what we'll do is, if I can share a new screen. Okay, so just let me know. Okay, so we have to do it over here. So if you look at this point where we have -1, -2, -3, and -4, we want to calculate the angle from this point to, let's say, this point, -4. So first we take this -4, 0, and we calculate the angle from this point to the 0 at -4. So do you have any ideas how are we going to calculate this? I want to calculate this angle theta, theta 1, and I want your ideas that how am I going to calculate this? G, do you remember trigonometry, sine, cos, perpendicular, hypotenuse?
Sir, Pythagoras function.
Yes, how? But no, not Pythagoras. So if I say that, do you know if I make a triangle over here? Okay. So this is exactly at -2, and this point is also at -2 plus j3. So this is the perpendicular that you see over here. So do you know that what is the length of this perpendicular?
Sir, J3.
Yes, it is equal to 3, not j3, but 3. The magnitude of length of this perpendicular is 3. How can is this clear to everyone in the class that the length of this perpendicular is going to be 3? Is this clear to everyone? Basically, this
Yes, sir.
point is at -2 plus j3. So 3 would be length of the perpendicular if we make a right angle triangle from this point to this 0 at -4. Is that clear?
Yes, sir.
Okay. So the next thing is that what is going to be the length of this base? G, what is going to be the length of this base?
Sir, 1.
No, we
2.
have the point at -2 and we have the 0 at -4. So what is going to be the base, the magnitude of base of this right angle triangle?
-2.
Yes, 2, not -2. We are talking about the magnitude. So basically, the magnitude of base of this right angle triangle is going to be 2, and the magnitude of perpendicular of this right angle triangle is going to be 3. Is this clear to all?
Yes, sir.
Since we have the point at -2 plus j3, so we know that the real access point for this point would be equal to -2, and the 0 is at -4. So the difference between these 2 points is equal to 2. And similarly, the height of this perpendicular is equal to 3, which is the value of the y-axis of this point. So the value of perpendicular, the magnitude of perpendicular is 3, and the magnitude of base is 2. I want each and every one of you to respond that is this clear to all? Or if you have a question, I'll repeat this about this right angle triangle and the angles that we are going to find out. 3 is basically -2 plus j3, the location of this point. So 3 is the magnitude of this perpendicular, since we know the value of y-axis of this point. Is that clear? Is that clear? You can ask again.
Yes. Yes, sir.
Okay. रिपीट, क्या कह रहे हैं?
सर को रिपीट करने समझ नहीं आई इस बात।
Okay, so we have a right angle triangle from this point to L1. Okay. Okay.
यस सर।
So now we are going to measure the length of perpendicular from this point and the length of base from this point. Okay. So in order to make this right angle triangle, the length of perpendicular is going to be basically the magnitude of y-axis of this point. So the y-axis is at the y-axis point is 3. So the distance of this point from a real axis is going to be equal to, I want you to respond if you're getting my point,
3.
that the, yes, it's going to be equal to 3. So the magnitude of perpendicular is equal to 3. Is this clear?
यस सर।
Okay. So now about the magnitude of base. This point at real axis is equal to -2. Since the location of this point is -2 plus j3, so the location of this point on real axis is -2, and the distance of this pole from this 0 of this point from this 0 is 2. Since the point is at -2 and the 0 is at -4, so the distance between these 2 points is equal to 2. Is that clear as well?
यस सर।
समझ आ रही है? सही से कोई मसला नहीं है, अगर नहीं आ रही है तो बताएं मुझे.
आ रही है सर।
Okay, so perpendicular is 3, the base is 2. So now what will we apply in order to find this theta 1?
So sin t by h.
But we don't have h, we have base and we have p. So perpendicular and base.
सर वो tan वाला फिर भी।
Yes, through proper brushing. Tan theta is equal to perpendicular by base. So theta is equal to perpendicular by base ka tangent inverse, right? So theta 1 would be equal to tan inverse of 3 divided by 2. Is that clear? Is that clear?
Yes, sir.
Now I want you guys to tell me what would be theta 2 equal to. So this is theta 2 over here, and theta 2, tell me the base and the perpendicular values.
सर परपेंडिकुलर 3 होगी और बेस 1 होगी.
Very good.
सर वो इब्राहिम को इन करना सर।
Okay. So Ahmad Ali is here, 222 is here, and somebody with name 91 is here. Ask them to change their name to some sane name, and I'll let them in. Is Ibrahim with the name of 91? Ask him.
यस सर।
Okay. Okay. So is this clear to, okay. So I want all of you to respond that what is the value of theta 3 then? What is the base of theta 3? In fact, I want you to tell me what is the angle theta 3 equal to. We are going to take angles from the positive x-axis always. So what is
theta
the
3
angle of
90
theta?
degree होगा.
Yes. Is only one student understanding this thing, or everybody, that theta 3 is going to be equal to 90 degrees? Yes or no?
Yes sir, perpendicular है।
सर
Yes. And why is it so? Because it's a perpendicular, since the point is at -2 plus j3 itself, and we have pole at -2, so the theta 3 is going to be equal to 90 degrees. Okay, so tell me what is going to be the case with theta 4. What is going to be there's something special that is going to be
सर वो
done in
cos
the
वाला
case.
फार्मूला लगेगा इसमें।
Formula cos wala. How, Sameer?
सर वो curly brown hairs तो हमारे पास बेस है
But we don't have
hypotenuse।
hypotenuse over here, Sameer. We have perpendicular and base in all the cases.
वो
One
थ्री नहीं
more
बनती
thing
उसके
that,
लिए।
सर 180 में से
नो
थीटा
नो
2 माइनस करें तो वो आ जाएगा।
थीटा थ्री में से थीटा टू माइनस करें।
सर 180 में से थीटा 2 माइनस करें।
180 में से थीटा टू या 180 में से थीटा फोर?
सर थीटा 4 तो फाइंड नहीं करना।
थीटा फोर तो फाइंड करना है। तो जो एंगल हमें मिलेगा यहाँ पर L4 के लिए, वो बेसिकली इंटरनल एंगल होगा। वो जो इंटरनल एंगल निकलेगा, वी आर गोइंग टू अप्लाई द सेम टेंजेंट फॉर्मूला थ्रू प्रॉपर ब्रशिंग। थीटा थीटा फोर कॉम्प्लीमेंट वुड बी इक्वल टू 3, this is perpendicular 3 divided by 1. So the theta that we'll find over here is would be the internal angle of this right angle triangle, and in order to find theta 4, we will subtract that internal angle from 180 degrees. So theta, you're right, that we'll find theta 4 by subtracting that angle from 180 degrees, but that angle is not going to be theta 2. That angle is going to be the internal angle of this pole, this right angle triangle. Is that clear to all? Yes, is that clear to all?
Yes, sir.
Okay. सबको समझ आ गई है कि थीटा फोर किस तरह से फाइंड किया जाएगा? Yes, I want you guys to respond. Don't sleep.
Yes, sir.
Okay.
सर जाग
So
रहे हैं।
after we find out these angles, theta 1, theta 2, theta 3, theta 4. So you see that here we have theta 1 and theta 2 corresponding to poles, and theta 1 and theta 2 corresponding to zeros, and theta 3 and theta 4 corresponding to poles. So the angles that he found out over here, theta 1 and theta 2 are being added, and theta 3 and theta 4, you see this theta 3 is equal to 90 degrees. So theta 3 and theta 4 are being subtracted. So the angle comes out to be 70.55 degrees, minus 70.55 degrees. Since this angle is not equal to 180 degrees, so we deduce that this point is not a point on the root locus, or this point is not a closed loop pole for any gain on the root locus of this system that we have designed over here. So the condition number 2, that was the sum of angles and poles of the sum of angles of the zeros and poles at that point should be equal to 180 degrees, is not being fulfilled over here, since the angle coming out is equal to 70.55 degrees. So if this angle was equal to 180 degrees or the odd multiples of it, then we would say that okay, this angle, this point minus 2 plus j3 is on the root locus. But since this point is not on the root, since this angle is not being equal to 180 degrees or the odd multiple of it, so the deduction is that this point is not on the root locus. And if a point is on the root locus, that point is basically a closed loop pole. That is a pole that comes on the root locus. But since this point is not on the root locus, so we say that this is not a closed loop pole of the system. Is that right? And is it clear to all?
सर हनान को लेट इन कर दें प्लीज।
Okay. So is this clear to all जो मैंने भी समझाया है?
यस सर।
Yes, sir.
Okay. So he says further in this example that if we take the point minus 2 plus j under root 2 divided by 2, this point over here, if I can highlight this. If we take this point, then he says that the angles for this point sum up to 180 degrees. So this tells us that this point, the new point, is on the root locus. And then after verifying that if this point is on the root locus, he puts this point on in the next formula, which is basically k g of s h of s magnitude equal to 1. And after putting it in this formula, he calculates the value of k is equal to 0.33. So how does he put it in the formula? You have the poles and zeros. So the transfer function is s plus 4 into s plus 3 divided by s plus 2 into s plus 1. So in place of s, in all these places, we are going to place minus 2 plus j under root 2 divided by 2. But when are we going to do it? We are going to do this after verification of the point that this specific point is on the root locus. So in your exams, in your quizzes, I'll be giving you different points and I'll make a question that please check what is the value of gain at this point on the root locus. So the first thing that you are going to do is verify that if this point really lies on the root locus or no. So in order to verify that, you are going to make a diagram like this, calculate the angles, sum up the angles, and if the angle comes up to be equal to 180 degrees or the odd multiples of it, the transfer function is satisfying this point to be on the root locus. So we will move further to this point that k g of s h of s magnitude is equal to 1, and in the place of s you would put minus 2 plus j under root 2 divided by 2. But if you see that this point results in an angle that is different from 180 degrees, that is like just like this example in 8.20, 70.55, 60, or whatever the value except 180 degrees or its odd multiples, then you're going to say that this point is not on the root locus. So there is no point in applying the second formula and finding out the gain. But if in any question I say that this point is on the root locus and you do not need to verify it, just find out the gain. So then you are going to apply this formula kg of s h of s magnitude is equal to 1, and you are going to substitute the point value in place of s. So is this clear to all? Is this clear to all that how are we going to check the existence of a point on the root locus, and then how are we going to check the value of gain k at that specific point?
Yes, sir.
Okay, I want everybody to respond. Zulkarnain, Saqib, Najam, Zishan, Romesa, Ariba, Samra, Abdurrafe, Maz, Burhan, Ahmad Ali, Noshirwan. Is this clear to all?
Yes,
सर ये
sir.
तो क्लियर
Yes,
है
sir.
चेक करना है, लेकिन वो फिर आगे किस तरह प्रोसीड करना है?
Saqib, can you please repeat the question again?
सर ये तो क्लियर है कि मतलब किस तरह चेक करना है कि 180 आ रहा है या नहीं आ रहा. अगर 180 आ
Okay.
जाए तो फिर आगे कैसे फर्दर प्रोसीड करना है?
Okay. So if the angle is equal to 180 degrees, we have the second condition that is kg of s, h of s is equal to 1. This. Okay. Remember?
Yes, sir.
Okay. So we'll put the point that is, for example, the point is minus 2 plus 3j. Okay. So if the point is minus 2 plus 3j, so we'll put that specific point in the transfer function in space of s, just like s plus 2 divided by s plus 3. So s would be replaced by minus 2 plus 3j, and then we'll take the magnitude of that, and if the magnitude and put it equal to 1, and then find out the value of unknown k. Is that
Yes, sir.
clear?
Yes, sir.
Okay. So anybody has any question? किसी और का कोई सवाल? Okay. So you see
Sir,
that there is
some
a problem in skill assessment 8.2. See, the time for this meeting is ending, so I'm going to start a new meeting. So we'll start a new meeting in 5 minutes. Okay?
Okay, sir.
Okay?
yes, sir.
Okay. Allah Hafiz.
Allah Hafiz, sir.